This is problem 2 from the energy mock test. The first question is, what's the total energy of these 512 kilogram cars at going 7.5 meters per second at an elevation of 11 meters? The total energy is just going to be mgh plus 1/2 nv squared. Right? So it's 512 times 9.8 times 11 plus 1/2 512 times 7.5 squared. And so I'm just literally going to put that into my calculator that way. This is 55,193.6. This is 14,400. And the total is 69,593.6 joules. Did you guys get that? Is that the answer I got before? Yeah, there we go. Okay. Then it says, what's the car's speed when it's at an elevation of 7.8 meters? Well, the same energy that's here is going to be the same total energy here and here, correct? Yeah? Boys and girls? So this is immensely important, is that I can take this energy, the original energy, and say that equals this or that equals this, correct? I don't need to go find the energy here and the energy there. They're all going to be the same, right? So this number, I can just use this number, right? So B is going to be, I can just use that number, right? 69,000, right? Which is just this, right? Okay, equals, and then what kind of energy do we have here? Well, kinetic and potential, right? So I can say that equals mgh plus m1/2 mv squared. Right, so and the height is 7.8. Yeah. So I'm going to take this minus this. Right, and now I'm going to go multiply by 2, divide by 512. And then I have to square root that. I get 10.9. Yeah? Is that all right? For B? You can also, if you don't like the idea of using the answer from A, you can just set this thing up as mgh. Right? And in that case, you can actually cancel the m's, and maybe the math is. Guys, can we be just a little more quiet over there? Just talk quietly among each other. And then this one for C, what are we getting in there? I give you a force and I ask you for the distance. Do you suppose that part C asks about work? Yeah, let's do part C. Yeah. Do you suppose it's asking about force times distance, though? It's basically hitting you over the head with that, right? Like, it slows you down or speeds you up? What kind is it? It's slowing you down stuff, right? So again, I can just say this total energy here equals that total energy there. I'll do that right here. So for C, the total energy before I've already calculated it is 69,593.6, right? And then that equals here, what kind of energy do we have here? When it's at 4.5 meters high and after the brakes have slowed it to a stop. You got potential and it's stopped, so it's work, right? It's just potential and work, so it's going to be mgh plus force times distance. That's where the energy goes. You still have some potential, but the rest is work, right? So now we can plug this in with 69,000. And that's why I have you in the first problem calculate what the total energy is, because you can just use that on the left side. Get it right, though. You know, that'd be sad if you got that one wrong. 512. It'd be sad for me because it would make it hard for me to grade. So now I'm going to take this minus this. Ah.
Yeah, I forgot to watch the joules over time, so I can understand.
Peregadinus, poking his head in a class, on his way to the can. Presumably. Okay, so this is 47,000. What? What? I thought you were making a joke. Hello. I'm not even, they're not even paying attention. Look at them. Are they paying attention to me? Just go for it.
Do you have, like, any time you're doing more experiments on the hall or anything?
Oh yeah, you know, we're going to do that thing where we push people up and down the hall for like the three-stage. You can look on your syllabus. It's on the syllabus, right? It's three-stage human rocket. That'd be a good one to take pictures of. Not so much lighting boxes on fire, you know. They want to take pictures of doing flashy stuff. So I know. He comes in and you guys are all just like, ooh. Are we good on that one?
I don't get number 3A.
3A? 3A. Oh, those are just power work time questions.
But what about watts?
Watts. That's how many joules per second, right? So time is going to be work divided by power, right?